Welcome to the DIY Honda Garage channel. The DTC P1659, which stands for Electronic Throttle Control System, ETCS, Control Relay Off Malfunction, is a diagnostic trouble code relevant to Honda Civic models from 2016 to 2021. This error typically indicates an issue with the electronic throttle control relay system. The electronic throttle control is a crucial component that regulates the airflow into the engine, ensuring optimal performance and fuel efficiency. This malfunction can affect vehicle acceleration and engine performance, posing safety risks if the system fails. For accurate diagnostics and troubleshooting, it is essential to use a proper Honda Diagnostic System, HDS tool. The subsequent slides will provide a detailed breakdown of the involved components, possible causes of this error, and a systematic approach to troubleshooting as per Honda's service guidelines. The ETCS control relay is a key component of the throttle control system located near the powertrain control module, PCM. Its primary role is to manage the electronic signals that dictate how much air enters the engine, directly affecting how the vehicle accelerates. When the relay experiences a malfunction, it can result in erratic engine performance or inability to accelerate, which may not only be inconvenient, but could also pose safety hazards while driving. This relay interfaces with various sensors and components in the engine management system, working to ensure that the throttle responds appropriately to driver input. When diagnosing issues related to DTC P1659, both the relay and associated wiring should be thoroughly checked to isolate the root cause of the malfunction. The potential causes of DTC P1659 can be categorized into several issues. Firstly, a faulty relay circuit board may prevent the relay from functioning properly, which is critical for regulating throttle input. Secondly, a blown fuse number A9, rated at 15 amps, located in the underhood fuse relay box, can interrupt power to the ETCS, causing the error. Lastly, issues with open wires in the relay circuit, either between the relay circuit board and the fuse or between the PCM and the relay circuit, can also cause malfunctions that trigger this DTC. Identifying these components and ensuring they are in good working order is essential for resolving the issue effectively. The symptoms associated with DTC P1659 can significantly affect the vehicle's performance. Drivers may experience poor acceleration, which can be dangerous when trying to merge into traffic or navigate steep inclines. Additionally, there may be a noticeable loss of engine power, making the vehicle feel sluggish or unresponsive. Most notably, the check engine light will be illuminated on the dashboard, alerting the driver to a malfunction within the electronic throttle control system. This error can lead to a frustrating driving experience and may require immediate attention to prevent further issues or safety hazards. The first step in troubleshooting the P1659 error is to turn the vehicle to the on mode, which allows for system checks without starting the engine. Next, it is essential to clear the DTC using the Honda Diagnostic System, HDS, a specialized tool for diagnosing Honda vehicles. After clearing, check for any pending or confirmed DTCs again with the HDS tool. If DTC P1659 reappears, this indicates that the malfunction is confirmed, and further investigation is warranted. If it does not reappear, the issue may be intermittent, leading to a need for inspecting connections and terminals at the relay circuit board and the PCM for any looseness or corrosion. In the second troubleshooting step, you will remove the relay circuit board to inspect its condition. Testing the relay circuit board is imperative to ensure it functions correctly. If the board does not pass these tests, it will confirm the need for replacement. It's essential to follow the manufacturer's guidelines when performing these tests to guarantee accuracy and reliability. Alternatively, if the circuit board is confirmed to be operational, you will proceed to the next step in the troubleshooting process, diving deeper into the electrical systems involved in the ETCS. For the third troubleshooting step, you will first turn the vehicle to the off mode, ensuring safety while working on the electrical systems. Next, locate and check fuse number A9, which is a 15-amp fuse located in the underhood fuse relay box. A blown fuse can cause a break in the electrical circuit and lead to DTC P1659. If the fuse is damaged, it must be replaced, and you will also need to inspect for shorts in the +B DBW wire between the relay circuit board and the fuse for further diagnostics. If the fuse is intact, you will then proceed to the next step. In this step, you will measure the voltage between designated test points while the vehicle is in the off mode and with the relay circuit board removed. Test point 1 is at the relay circuit board connector C, and test point 2 is the body ground. The aim is to determine if battery voltage is present through the +B DBW wire. If sufficient voltage is detected, you can conclude that the wiring is intact, and you will move on to the next check. Conversely, if there is no voltage, this indicates a problem with the wiring that requires repair between the fuse and the relay circuit board. During the fifth troubleshooting step, you will first jump the SCS line using the HDS and ensure to wait for over a minute to stabilize the system. After this, disconnect the PCM connector A, which contains 50 pins. This is a critical step, as you will then check for continuity between test points while the vehicle remains in the off mode with the relay circuit board removed. Test point 1 is the female terminal number 1 of the relay circuit board connector C, and test point 2 is at the PCM connector A, pin 16. Confirming continuity means that the FI sub-Riley out wire is functioning well, and you will continue to the last step. If no continuity is found, repairs must be made on the wire between the PCM and the relay circuit board. In the final step of troubleshooting for DTC P1659, you will need to check for continuity between 2 additional test points while still ensuring the vehicle remains in the off mode and the PCM connector is disconnected. Test point 1 is the female terminal number 2 of the relay circuit board connector B, while test point 2 is at PCM connector A, pin 25. Confirming continuity indicates that the FI sub RLYCL wire is also functioning correctly. If continuity is absent, repairs must be made to this wire. Additionally, if any service information related to DTCs or any symptoms arises during these checks, it's essential to consult authorized service documents or consider substituting a known good PCM as the last resort. After completing all troubleshooting steps and associated repairs for DTC P1659, it's crucial to verify that all components are functioning correctly. Carefully recheck each part you have tested and repaired, ensuring proper connections and functionalities. Next, clear the DTC using the HDS tool to reset the system. Following this, conducting a test drive is essential to replicate normal driving conditions and confirm that the issue no longer reoccurs. Monitor the vehicle performance to ensure that acceleration is smooth and the check engine light remains off. This process validates that the repair was successful and the vehicle is operating safely. To prevent the recurrence of DTC P1659 and maintain optimal performance, regular inspections of the throttle control system and associated components are highly recommended. Make it a routine to keep all electrical connections clean and secure, as corrosion or loose terminals can lead to faults in the system. It's also beneficial to monitor your vehicle's performance closely, especially when experiencing any sudden changes in throttle response or acceleration. Ensure timely maintenance as per the manufacturer's guidelines to avoid any unexpected malfunctions. By staying proactive in vehicle upkeep, you can substantially reduce the chances of issues arising in the electronic systems. In conclusion, understanding DTC P1659 and its implications is essential for maintaining the performance of your Honda Civic. Following a structured troubleshooting approach allows for a methodical resolution of issues related to electronic throttle control. Key components, such as the relay circuit board, fuse, and wiring, need careful inspection and testing to accurately diagnose and resolve the malfunction. Adequate preventive maintenance can mitigate many issues, enhancing vehicle reliability and driver safety. By utilizing this guide, you will be equipped with the necessary steps to tackle DTC P1659 confidently and ensure your vehicle performs at its best. Please like and subscribe to the channel. See you next time.